Our standard view of SETI, at least from a scientific perspective, has generally been one of distance. Ever since Cocconi and Morrison released their landmark paper in 1959 describing how we might search for artificial radio beacons emanating from deep space, we have generally envisioned that a provable detection of an alien civilization would come in the form of a distant, verifiable radio signal. But there has also been a trend in recent years towards things like non-radio technosignatures of alien civilizations, and even biosignatures emanating from life itself on exoplanets. What is usually left out is the idea that such contact may come from much, much closer, perhaps even within our own solar system, or even the vicinity of Earth. The big problem with this kind of idea is distance and time. Here we ask an alien civilization to send a probe across vast distances of space and time to sit here indefinitely waiting for us to contact it or some similar scenario. While most of these scenarios are more fiction than reality, there are ways for it to be possible. My guest today suggests that not only is it possible, but it may be just as likely for us to find evidence of alien civilizations within our own solar system as it is that we might find them by other means.
You have fallen into Event Horizon with Jonh Michael Godier. In today's episode, Jonh is joined by Dr. James Benford. Dr. Benford studied physics at the University of Oklahoma and in 1969 received a PhD in physics from the University of California at San Diego. He then worked at Physics International. In 1983, he investigated the use of pulsed power technology for high-power microwave generation. Dr. Benford developed a variety of microwave sources at very high power levels, built the largest high-power microwave experimental facility in the US, and developed a research group working in the areas of microwave source physics, microwave beam propagation, and microwave effects on electronics. His current interests include phase control of high-power arrays by phase locking of oscillators. His past experience includes work on electromagnetic launchers, pulsed power design, system studies, and the use of electron beams for many applications.
Dr. James Benford, welcome to the program.
Glad to be here.
Now, Doctor, you are an advocate for a very interesting area of SETI, and a somewhat new area of SETI, looking for artifacts within the solar system that alien civilizations might have left here. Now, this is an idea that goes back a long way to Ronald Bracewell and maybe even before, where someone might have stationed something in the solar system to eventually perhaps establish contact with us. Now, can you give us an overview of how likely is that in the context of SETI at large?
Well, I argue in my latest work that it's about as likely as listening to beacons for success. That is, that beacons can be detected at great range, but you have to catch the signal as it flies past, and so that you're limited by how long they broadcast. Artifacts, on the other hand, would come from relatively nearby, from stars that are passing by, say within 10 light years. But on the other hand, once they're here, they'll stay here because they certainly aren't going to go back. And they would probably stay on objects close to Earth, such as the Moon or the nearby Lagrange Earth Trojans at the Lagrange points, and also the CoOrbitals, which surround Earth and have only recently been discovered.
So the CoOrbitals, now these seem like natural places to perhaps place such a probe, and it reminds me, I think, of how we look at radio SETI with the 1420 megahertz watering hole as perhaps a natural place to put a radio signal. And it seems to me that the CoOrbitals are natural places to put a probe. Now, could you give us an overview of these different types of CoOrbitals?
They fall into several classes. they fall into what is called a horseshoe orbit that approaches Earth about once a year, and the ones that come closest are in that kind of a orbit. There are the Trojans, that is those that sit on the launch points, which are stable points about 0.6 of an AU, that is about 60 million miles away from Earth, but are stable for long periods of time. And then there's the quasi-satellites, which are very close and appear to be second or third moons of Earth, because for a while, typically for tens of thousands of years, they circle the Earth, but they're actually simply going around the sun at the same rate the Earth is, and so appear to us to be orbiting around us, because they go through the year, go slightly inward toward the sun and slightly outward, and therefore they appear to orbit the Earth at distances that are on the order of 10 to 100 times as far away as the moon.
Now, I remember some years ago, it's been a while, there was a candidate asteroid that was seen that at first looked somewhat unnatural, to the point everyone wondered if it was a spent booster that no one knew about, or if it was perhaps a Bracewell probe. But it turned out to just be a rock. But do you remember that, and what class was that in?
That was in the class of a co-orbital, and they thought, in fact, it might have been a leftover from the Apollo program, and because the rocket that propelled the spacecraft toward the moon was then allowed to fly on and go into orbit around the sun, and some of them come back occasionally. That one was, in fact, turned out to be simply something that had been expelled from the asteroid belt and was passing by just about the right speed to match speed with Earth. The real discovery in this area took place about 1997, when the thing we now call Cruinia came very close to Earth, and is thought of as they're in that class of co-orbital class of being second or third moons of Earth, because they'll be around for quite a while, maybe several thousand years. It will be, and comes pretty close to within about 10 million kilometers of Earth on a pretty regular basis. That was discovered 23 years ago. Many others have been discovered since that time that fall into that class.
Now, how would we know that they are asteroids as opposed to objects of alien origin?
Well, first of all, you look at them and you see if they have the spectra of a rock, then they're probably a rock. On the other hand, a spacecraft coming out of interstellar space could launch itself onto such a rock, and we would think it was all rock. If it were only a spacecraft, then our spacecraft are very noticeably different, because they're highly reflective to keep the temperature down, and so they are much brighter, and they would have a metallic spectrum. So far, everything that's been looked at is rock, but that's only one or two objects. Most of them we have not looked at the spectrum at all, and so we really don't know what they're made of. We do know that so far, none of them have been bright objects, but they've all been rather dark, which is what asteroids are typically.
There are things that we might be able to do if these things are passing close that might provoke a response. Could we paint this thing with radar from, say, Arecibo? Could we do that and perhaps activate it if such a thing was found? Or could we listen passively, with radio telescopes? Or are these things just simply not suitable for that kind of investigation?
Oh, they're entirely suitable for that. The radio telescopes we use for the SETI purpose now could at least listen to them. Optical and infrared telescopes can image them. A planetary radar, which we use to investigate asteroids, could ping them and, in fact, get a return signal from the nearest of them. The majority are too far away for a return signal with our contemporary radars, but we can certainly have a program of observations and passively watch them. We can have active planetary radar to investigate the properties of the objects, and we could conduct active simultaneous radar painting and SETI listening to see if we get a response. That would be a more advanced phase. Of course, the ultimate advanced phase is to launch a robotic probe and missions to actually look at them. And in this regard, the Chinese are planning to send a probe to the nearest of the CoOrbitals a few years hence.
Should we do that? Do you think it's safe? Because it's a different thing if you get a radio signal from 9 light years away and you say, well, we could respond to that. That's, people, question that enough with METI. But this would be an object that's very close to us, to Earth. So do you think it's prudent to do that? Do you think we actually should proactively do that? Or because there's just no reason not to, because it already knows we're here? Or should we play it safe if such a thing was ever discovered?
Well, you put it very well. They would be here to look at Earth, so they surely know we're here. So we cannot, in fact, announce ourselves because we're already radiating plenty of electromagnetic radiation. And in fact, a good-sized telescope could see our cities. In fact, even a small telescope would see on the night side of Earth the illumination of the cities. So there's nothing to lose from doing this. The basic question of METI is, do we really want the aliens to know about us? That's a question you can ask about responding to a signal from a distant star. But to talk about worrying about something that's already here to look at us seems to me to be overly conservative, shall we say.
It also has to be said that Earth gives us away anyway with its biosphere, and that we have been visible because of the oxygen in the atmosphere for a very, very long time. So what are the limits on how far away a civilization that's studying Earth as an exoplanet could actually send such a probe? I would imagine it's very difficult to send it across a galaxy, but what is the radius where this seems likely and not too expensive to actually do for an alien civilization watching this world?
Very, very good question. And because the galaxy is, as you know, 100,000 light years across, we have concepts for interstellar probes that would go at, say, 1/10 of speed of light. And you could therefore do a mission to Earth from the nearby stars in timescales of about a century. That is, it would take them about that long to get here. And then they could reside for a long time. The real question is, how long is the attention span of the people sending the probe? Because once you've launched something to 1/10 of the speed of light, it can go a long way. You just have to be willing to listen to the return signal for a long time. Once it gets there, suppose it's 3 centuries later, you should be prepared to listen to what it reports. There's nothing comparable to that time scale in the history of humanity, because the longest voyage we've sent anything on Earth is only 1,000 days. That's from England to Australia. But the longest voyage in space is, of course, the Voyagers themselves, which have been flying now for about 45 years almost, and have gone a fair distance out toward the nearby stars. But it would take them many millennia to get to a star. The key thing is, what velocity can you get the probe to? We have reasonable concepts for a few tenths of the speed of light. Beyond that, it's energetically very different matter, very difficult. It would be a much more advanced technology than we would know how to do. I think we can build probes at 1/10 of the speed of light, of that range, this century for sure, and we'll do so. There is a program now, the Starshot project, sponsored by the Breakthrough Foundation, that plans to send probes to Alpha Centauri in a couple of decades from now at 2/10 of the speed of light, using a beam-driven sail. So that's our present concept for how you send something that was a flyby mission. Now, to stop and stay in the destination star system, you'd need to decelerate, which means it's a more difficult problem. You could use rockets, of course, but the rocket equation is pretty prohibitive for doing that. Such a starship would be the biggest object we'd ever built, and also almost the most expensive, on the order of $50 to $100 billion per ship. If you use sails, you could use a superconducting loop, which carrying a current interacts with the magnetic field of the galaxy and the target star to decelerate. And that deceleration would take a few decades, but then that's the time scale of traveling to nearby stars. So I would say the range about which your original question was, what's the range over which they might launch to us? And I think it's tens of light years probably. But we have to recall, and this is not widely known, that stars come near Earth quite often. And in fact, we had a very recent visitor. Solstice star came within 0.8 of a light year 70,000 years ago, fled inside the Oort cloud. And such close visitors, we get something coming within a light year of Earth about every 500,000 years, and coming within 10 light years about every 5,000 years, which is, let's put it this way, since the end of the last ice age and the rise of civilization, 2 stars have newly come into within 10 light years of Earth.
That's an interesting point, Solstice star particularly, because we may not have heard the last of that encounter, because as I recall, if it disturbed any comets from the Oort cloud, they're not here yet.
Oh yes.
But those kinds of encounters, I remember that there's actually another star that is spectrally so similar to the sun that it probably formed within the same nebula. And as I remember, it's a very sun-like star. So at one point, that star was close to the sun, or these other ones. And once you get to a certain period of time in the past, you can't tell what stars passed by. So you could have had a civilization that passed by here 1 billion years ago and planted these sorts of artifacts, right?
Yes, that's the easy thing. The great virtue of looking for artifacts is their lingering endurance. Long after they've gone dead and the stars passed, they would still be lodged where they landed, on a coorbital or the Earth Trojans or the moon. And they could say, therefore, we're talking here about an ETI archaeology. The Earth has been observable as a biosphere for a couple of billion years. Many stars have passed by. And the Bracewell probe idea of 50 years ago was, well, another civilization would come to look at our civilization. I think it's much more likely they came to look at the biosphere, biospheres may be quite rare. But this biosphere is observable from thousands of light years away, because all you have to do is to get a spectrum of the atmosphere and see that it's out of equilibrium, has a lot of oxygen in it, and therefore they could have been sending probes for billions of years. So if you put those numbers together, as I have done very recently, you find out that the probability of finding an artifact and the probability of listening to a beacon that is the SETI approach, are about roughly equal. And therefore we really should have, as part of the program, looking for artifacts. The other advantage we have right now is that, in contrast to proposals made about this matter 50 years ago, we now have a very robust, well-developed probe technology for exploring asteroids, the moons of the planets, planetary surfaces. We're very good at that. We've got good cameras, good probes, and we have many ways. It's very easy for us to go out into the solar system. There are planetary probes launched every year. So we're now able to do something that 50 years ago was difficult and in its early state.
The Drake equation. What can one plug in regarding the solar system? What can one plug in to determine a probability at all?
Well, what I've done is to compare the two methods, that's listening to the stars or looking for artifacts. What I've done is write out an equation, a Lurker Drake equation, and compare it to the standard Drake equation by taking the ratio of the two. Now, in both cases, the presumption is that an advanced civilization exists around other stars. So if you take the ratio, all those factors that lead up to civilization cancel out. One's in the denominator and the numerator, and therefore they cancel out, and you're left with only a few other things. You're left with two factors. Basically, what's the fraction of those stars that would send probes divided by the fraction of them that would just build beacons but not send probes? That's a number that's got to be less than 1, but we don't know what it is. On the other hand, the other factor that remains is the time that the Lurker would be, that this alien probe would be in the solar system, divided by the time that the ET civilization would radiate toward us. That number is surely very much larger than 1, because once they're here, they'll stay, whereas beacons will be on only as long as they have the patience to radiate at this solar system. Therefore, it comes out that it's at least as likely that we would find an artifact that we would hear a beacon. So I'm arguing that although it's great for us to be listening to the stars, we really have another possibility that we ought to be looking at, and we can now do, and that is, let's look at the objects near us and perhaps even send probes to these objects and see if anything's come to look at us.
Now, what of the moon? It seems to me that the moon might be a natural place to put some sort of monitoring station to look at Earth, essentially a Arthur C. Clarke type monolith. Is the moon suitable, or is it just subject to just too many problems like lunar gardening and things like that might damage the probe over a long period of time? Or is it the same in space? I would imagine it's going to get damaged in space just as much. How is the moon as a candidate to look for any type of signals or evidence?
It's actually a very good candidate, because something would live on the moon, stay on the moon for a long time. It takes a long time to erode away, say, a suitably built space probe. And the other thing is that we have very high resolution photographs of the moon now. Millions of them, approximately 2 million, made by the Lunar Reconnaissance Orbiter in the last 11 years. Very, very few of those have been looked at because of limited manpower, and we haven't developed an AI that would inspect them to first order to see if there's anything that looks artificial on them. All that we've really done with those photographs is look at the objects we've already put on the moon, such as the Apollo landers, where we can see things like Neil Armstrong's footprints, with the resolution is down to about a foot, you see. And the other thing we look at is interesting pieces of geology. But the vast majority of the surface of the moon we have photographed and not looked at. So it's a very good candidate. There are some negatives to it. The moon is in shadow half of the month, so it's cold, and any probe that would be active there would have to have energy storage to operate through that night of 2 weeks. If it could be solar powered, but it would have to be able to store half of the solar energy. So, moreover, the probe's going, if it would respond to us, it would surely have done so by now, respond to the many transmissions we've made to the moon for communication with our orbiters and landers. So it's clearly not responding, but it still could be there. I would say it's the probability is that it's dead, that it's inoperative. So the moon is a very good candidate, I think, because it's been there for many billions of years, and it's a pretty secure location. But we haven't looked well at it adequately to find something that, say, would be on the scale of an automobile or a house. We haven't really looked at the photographs we already have.
We were talking earlier about Starshot. Now, Starshot, let's reverse this. Say we're a civilization that is in the Alpha Centauri system. Is this idea simply too small to realistically for them to detect, or does this actually present a technosignature to the civilization that the probe is moving towards?
You're asking, would if we saw a Starshot probe coming through, would we be able to detect it?
Yes.
Essentially, no, because the Starshot probe will be on the order of less than 10 meters in size, very diaphanous, and flying at such a speed that it will pass through the solar system in a matter of a few hours. So the fact that we have recently seen 2 objects come out of interstellar space, the first Oumuamua and the second a comet, clearly from interstellar space and departing to interstellar space. But we didn't catch them until they'd been around for quite a while. In fact, Oumuamua was on its way out by the time we saw it. And that's a big object, relatively speaking, compared to Starshot. Oumuamua is on the scale of 100 meters or so, and therefore much larger than the Starshot probes will be, but going much slower, of course.
Now, regarding Oumuamua, do you think that there was an enormous controversy, I suppose, that it might have been artificial or of artificial origin? What's your view? You think it's a non-starter or maybe?
I think it's likely a natural object. I don't have a strong opinion about it. My friend Avi Loeb of Harvard has advocated that we look strongly at this question, and there I completely agree with him. We need to think about how we're going to identify such objects. Because we've now got the ability to see them, and we need to be able to decide what distinguishes an artificial object from a natural object, and what would we have to do if we wanted to intercept one. Some work has been done on that, but we do not have the fast response probe launch capability that we would need in order to catch up with such a thing. Now, on the other hand, if we build Starshot, it would be able to launch probes that are fast enough to catch up and follow such objects readily. And in fact, even in the early stages of the development of Starshot, it would be able to send small light probes with a camera on it to match velocities and see what these objects were.
Now, that's interesting. Starshot will not only give us the ability to head off to explore Alpha Centauri, but also it's useful to catch up to interstellar objects. I have never heard that before.
I don't think anyone but myself has ever said it.
Well, look, we have instrumentation coming online. The LSST, I think now called the Vera Rubin Observatory, is going to, it seems like that is going to reveal interstellar objects to the point that we may not even be able to keep up with how many of them there actually are. And which is going to be exciting, of course. But what do you think about the idea of, you mentioned Dr. Loeb, what do you think about his idea that maybe civilizations leave buoys at the local standard of rest, the galactic local standard of rest, and that our solar system runs into them? Is that a less efficient way of doing it as opposed to just planting them as your star system passes by? Or even, one could say, von Neumann's probes, where they self-replicate and apparently can colonize the entire galaxy remotely. What makes the most sense to you energy-wise? If you're an alien civilization, you're going to say, I want to do this economically, this surveillance. What's the best way?
I think sending a probe directly to solar systems of interest that you can identify from astronomy is the most efficient thing to do. The von Neumann probes, of course, if they existed, would already be here, and they aren't. So I think that they have a shut-off mechanism that prevents them from endless replication, probably, if they ever existed. The placing a buoy, so to speak, and letting stars come past presumes that you can make something that's going to exist for long enough and going to maintain itself for long enough on astronomical timescales. And I think that's rather doubtful. It's certainly not the first thing one would do, because right now we have probes that at most last a few decades. You could argue that we could probably try with present technology to make something that would last a century. But the idea of lasting for, say, 1 million years is a technology that would require the probe to repair itself. And that means a pretty sizable probe. And I think that is a more advanced technique than early civilizations such as ourselves can contemplate doing. So a very advanced society might have a whole network of objects around the galaxy looking at everything, in which case, why haven't they will surely have noticed us, and we haven't heard from them, so we're back at the Fermi paradox again.
What of the other collection points that might be possible for artifacts? What if Jupiter, and are there other places we might look that are further away than near Earth?
Yes, and of course, one over R squared, that is, means that you've got to have a much bigger aperture to observe Earth from far away. Recall that our images of planets were very poor until we were able to actually send probes there. and then we discovered all kinds of interesting things. So you really want to get up close and personal with an object to find out what's there. Jupiter is not particularly interesting, I think, to place a probe at because of the enormous amount of radiation in its magnetosphere. Would be really damaging to electronics. We're pretty sure we don't see anything there on a very limited basis of the probes we've sent. But I think if you come all the way from another star, why would you stand off at a great distance? Why wouldn't you get close to your subject, like the moon or the Earth Trojans or the CoOrbitals? It's just so much easier to see things that way.
What of, I had to bring up a science fiction scenario, and we have to take a break in a minute, but what happens if Earth long ago wasn't really that interesting and they were more interested in Mars, or perhaps an ice shell moon like Europa or something like that? Should we look for those just as much as we look for ones that monitor Earth?
Well, certainly that would argue that we should look at Phobos and Deimos, the moons of Mars, and see if there's anything sitting on them. Now, the limited photography we have had from, I believe, a Russian probe that went very close to it, is that we didn't see anything artificial there. But, of course, you might look on the surface of Mars, too. And there we have photographs with resolution down to about 6 meters, as I recall, over almost the entire surface of Mars now. Well, on the other hand, like the moon, we haven't looked at most of them. There's just so many of them. We've looked for interesting geology, but we haven't looked at many of the photographs because it's just a big planet. It's got a big area, much bigger area than the moon.
And on that, we have to take a break. I'm joined today by Dr. James Benford. We'll be back in a moment. And we're back with Jim Benford. Now, Doctor, it seems to me one way to identify an object, especially if it's a dead object, an extinct artifact, is, of course, spectra. What would you expect from the spectrum taken of an interstellar probe? I mean, what might that look like that sets it so apart from anything natural? Or would it actually accumulate dust over time and be indistinguishable until you actually dusted it off?
I don't know what would make dust stick to it, actually. The initial signature of when you look at something like our probes is you see something that's very metallic. It's made of metal. If you saw a signature that looked like a rock, it's probably a rock, because we don't build anything out of silicates. We do build solar panels, which are not metal, but at least not entirely metal, and there are other things. But maybe the biggest signature is something you don't think about, is glint. You know, probes are angular. If you look at them, they've got a dish and flat surfaces and round surfaces. And so you get what is known in radar as glinting. And you can detect an artificial object by the fact that the return signal in light or radar will go through substantial oscillations as the object rotates, or your angle to the orbit changes if it's moving across the field of view. So glinting is a way of detecting artificial objects that we have used in order to relocate some of our probes that we've lost. In particular, JPL recently identified, rediscovered dead orbiters around the moon by getting a radar signal that had a lot of glint in it. And we're able to reestablish what its orbit was. And that's a probe that's 250,000 miles away, roughly, and of a dimension of 1 or 2 meters, typically. And so that's a technique that you can use to identify an artificial object, is glinting, because asteroids and other such objects tend to be roundish, don't have strong angular features.
As I recall, what we discussed earlier, that asteroid sort of glinted in a rather odd way, which is why everyone wondered if it was man-made.
That's right. That's right. That is an indicator of artificiality. It's not a absolutely final slam dunk indicator, but it was an unusual object, Oumuamua, because it seemed to be a long cylindrical. And there you recall, of course, the great novel by Arthur Clarke, Rendezvous with Rama, in which a large cylinder.
We should have named it Rama.
We should have, In fact, I called it the Shard because there's a building in London that looks very much like a Oumuamua that's called the Shard.
I've seen it. Yeah, absolutely.
And it probably is. It probably is a shard, the Oumuamua, of a larger object that got somehow disrupted, and some of it flew off out of its solar system and flew by us.
Are there any other candidates you've ever heard of for glinting?
Well, yes, these certainly we've seen glinting in the discarded Apollo rockets that have come back again decades later. You see those as looking metallic and glinting. And so we've been able to understand an artificial object from these observational techniques in the past.
Now, to phrase it another way, we have the great unexplained wow signal within radio astronomy that we don't know what that was, but maybe. Have any radio transmissions ever been detected throughout the history of radio that might have been one of these probes saying something or at least reflecting on radio?
There is historically a phenomena of reflected radio signals. I shouldn't say reflected, but radio signals which broadcast on Earth, say, in the 1920s, and moments later we get an echo of them. And at a transit time that's much longer than it would take to go anywhere on Earth. And those have never been completely explained. That was about a century ago, and there's still a bit of a mystery. And people have thought that it was some kind of phenomena of the waves getting trapped in the magnetosphere and then being detected again. Of course, back a century ago, we didn't know there was a magnetosphere, so it was not a phenomena that we would have thought of at the time.
Are these still seen? Now, I remember these are called long-delayed echoes. Do, I don't know, ham radio operators or anybody else still see these?
Yes.
Or does anybody look, or is it just something that's fallen off the radar?
Well, it's largely fallen off the radar. Very few people in astronomy have ever heard of them. In fact, I had lunch last year with Martin Rees, the Dean of Trinity College London and formerly the Royal Astronomer, and told him about this. He'd never heard of it, although he has a deep history in astronomy. And that's true of every astronomer I've talked to about those return signals has not heard of it previously. So, yes, people do still see them, or rather hear them, but nobody's published anything about them in quite some time. I think the last paper about them was in the 80s, and they really haven't been thought of as too surprising, although we never did a research program to actually find out if we could prove where they came from and substantiate this idea that they're echoes produced by the magnetosphere. That's not been really resolved.
Doesn't there seem to be a certain logic, though, to the idea that a probe receiving a signal from a planet might repeat it back in an unnatural way, such as a delay, and say they're going to know this is the initial message because there's no other way that this could happen except artificially, right?
Well, that would be the idea. I mean, the simplest way to respond to a message is to send it back. Of course, the next simplest way is to, if you say photographed it, is to simply transmit the image in some fashion that could be easily interpreted. So there are several things you can do to respond. You don't have to know an alien language in order to respond to an alien message. You can do things like repeat the message with some change to it that indicates intelligent activity. For example, somehow invert the oscillations and change the phase and things like that. So there are a lot of ways you could respond if we ever heard anything that we thought was artificial.
Now, it seems to me that it would be significantly easier to send a message from very close like this rather than trying to send a message with radio over long distance of the interstellar medium. So a close probe could do things like count down prime numbers or something like that much more easily recognizably than a distant radio signal, right?
Well, of course, yes. For 1 over r squared is a really tough law. That is the fact that you'd have to have 4 times as much power to produce the same signal strength at twice the distance. So building a beacon to transmit over, say, 100 light years would cost on the order of $1 billion for it to be really observable by today's radio telescopes. But having a probe near Earth, say on the moon, well, we know that transmitters from the Apollo landers were easily detected on Earth, and they were at the level of watts. Really not very powerful because of that 1 over r squared. So you could send some very sophisticated messages, detailed messages with fairly low power toward Earth from a short distance, what I'm calling astronomically short distance, that is.
If a probe is present and active, assuming that, and it's looking at us right now, do you think it's likely time for it to activate and say, here I am? Or do you think it might be waiting for something in our future that we haven't done yet? Are we already contactable? Is it worth contacting us? Or can you think of some point in the future that might activate such a probe that we haven't done yet?
Well, the immediate thing we could do that I'm really recommending is that we start using our radars to paint nearby corridors or the moon with a message and see if we get anything back. Now, we know we sent many messages to the moon to control our own objects there, and we're not getting anything back, so that's probably not a good idea. But the CoOrbitals, which are hard to see, we only discovered them in the last decade, most of them, are completely unexplored. That is, we don't have images of them. We've taken a spectrum of only 1 of them, and we've found about 15 or 20 of them. We don't know much about them except where they are. They're points of light in photographic images. But sending a message to them, pinging them, so to speak, and listening to a response would be the very first thing we'd think of doing. In fact, it might be worthwhile, since there might be probes out in the Earth Trojan orbit, to send a signal out there and see if you get any return signal. No one's done that.
Now, another thing that strikes me regarding this is that, okay, go back to the scenario where you're an alien civilization passing by. You're on a star system that's just passing by this one that has this interesting exoplanet on it that's probably going to produce a civilization at some point. It seems to me that, number one, communications times are completely different for this because you don't have to bounce radio waves back and forth, over, you can download the data later, but the communication is almost instant if the probe is right here, which opens up interesting possibilities, I think, because what if that probe has been sitting there somehow for billions of years, and the ultimate message is, here is the entire natural history of your planet, photographs of dinosaurs or something like that, or footage even, or whatever. What do you think a civilization could give us through communication with such a probe?
Well, they could tell us about themselves. I think the best message that you'd send is, you remember the old phrase, you never get a second chance to make a first impression. I think if we were to send a message about ourselves, I'd send a series of images, because images are interpretable, and they've got to be visual beings in order to be space travelers. And I'd send images of things like the Taj Mahal, beautiful things. I'd say, here's the best we've done. An image of a rocket lifting off, an image of the pyramids, the Eiffel Tower, images of beauty, the Mona Lisa, Picasso. There are just a lot of images we could send, and that's what I would do. I'd send. Ask yourself this: what would you like to receive? And that tells you what you should send.
I often wonder if we ever found a passive artifact, a dead artifact that some civilization sent us, in our case, we essentially sent out some space probes, but we also sent out a Tesla. So some wandering civilization passing through, and however many years billions of years or millions of years, actually probably less than that, but they're going to find a car and they're going to be like, what were they thinking? So I also often wonder if we just find a piece of concrete, rebar concrete or something passing through the solar system, or a piece of trash, because civilizations seem to produce an enormous amount of trash. Do you think that such an encounter might end up being ignominious like that? Or do you think it's going to be some really, really carefully planned thing? Or do you think it's possible we might just find some alien trash?
Well, we might well. My favorite in that is the concepts for detailed concepts that have been made for starships, Daedalus and Icarus and Firefly, all have fuel tanks that they discard along the way. And those fuel tanks will fly through the alien solar system as well. And they might actually be bigger than the payload that eventually gets there. And so if we saw a bunch of flying objects which were almost the same but in cylindrical, and we might not even notice the payload that they launched because they show up after the payload's already flown through, and they're much bigger than the payload. So that's the kind of trash that would be interesting to find and intercept. But of course, they'd just be an empty container.
An empty container would answer the question, though. We are not alone. So it would be the most important empty container in human history.
Yes, right. Clearly artificial, clearly alien, and clearly ancient. All of those would apply and would be a great discovery.
You've also worked in SETI in the past in further things. Like, for example, I think you wrote a paper on pulsars.
Yes, on how would you distinguish between a pulsar and an artificial beacon.
Tell us about that.
Well, pulsars were, when first discovered, thought to be artificial. The living green men, LGM, but we now know that we think that they're associated with spinning compact objects. And on the other hand, let's think of it this way. How do we signal to the distance that there is an object here? The obvious thing is the lighthouse, right? And the lighthouse goes off and on. You want to make a pulsed thing, the pulse image, pulse signal that would be noticed. Well, little known thing about lighthouses is that each one of them rotates at a slightly different frequency. So if you measure the period, you know what the lighthouse is. You know where you are. They're not all the same. So I think pulsars should be looked at as potentially artificial. And there's actually some people who have looked into that fairly extensively and come to a conclusion that they certainly have a changing spectral distribution, and that's probably due to the physical origin of the radiation. But nobody's ever looked for a signal in them. Nobody's looked for a modulation. So I don't know if that's possible. I think it's a very remote possibility, but it's a remote possibility we ought to think over, because we have observed many thousands of pulsars, and I think some effort should be made to try to understand if there's any sign of artificiality in any of them. After all, they could be all, for the most part, natural, but some of them artificial. By the way, pulsars are now considered to be probably the best way to navigate interstellar space, because we know where they are, we know their period, and we know exactly when they come on and off. And so we can use it to triangulate the location of a ship that's going through interstellar space.
I think as far as what we were talking about earlier with things that have been forgotten, I think a lot of people probably don't realize that the questions of the artificiality of pulsars has never been closed. That is still an open question.
Yes. Now, of course, the pulsar astronomers would denigrate that idea, because there's a default in astronomy. Everything is assumed to be natural, and nothing is thought to be artificial except things we clearly do. And that's a kind of a bias that astronomers have, that surely there must be a natural explanation. And yet, the evidence today, in contrast to half a century ago, is that we would think that life is fairly common in the universe, but we haven't really changed our thinking to increase our recognition of what an artificial object would be.
What do you think of the WOW signal?
My friend Robert Gray, who has spent a lot of time and written an entire book about it, thinks that it's just a deep mystery that we ought to keep listening, and we ought to see if we ever pick up anything. And thus far, they've expanded the parameter space they've looked at, but they have still not seen it again. It's too bad that in those days when we saw it, I think that was back in the 70s, we didn't have sufficient instrumentation to see if there was a message encoded in it, which is what you'd expect if it were artificial. On the other hand, I've always thought that there was another possible explanation, that it's really leakage radiation from something like starshot. That is, a powerful beam that hits the sail and accelerates it, and some of the beam is somewhat bigger than the sail, and we see the leakage of that over interstellar distances, and we see it only transiently, and we may not be in alignment where we would see another one for another 10 years because they're sending beams off in various directions depending upon the mission. That is a possibility that astronomers really don't like because they're not really set up to look for transients. They see a lot of transients in astronomical radio observation, but if they don't repeat, they don't think of them as possible SETI signals. But I think that leakage radiation from power beaming is going to be much more luminous than beacons, for example, because they're very powerful. They have to accelerate an object, and they are very directed. So I've actually written a paper with my son about that and pointed out that it's the most highly observable thing we could do would be starshot. It would be visible across the galaxy. And yet the SETI community is not really set up to look for such things.
So you think there are biases within how, well, of course there are. I mean, how does one look for something that they've never seen before, such as an alien signal? Mm-hmm. So you think there are biases within SETI into, we should broaden our approach much, much more than has been so far?
Oh, yes, definitely. There's a bias that everything is certainly natural and not artificial. There's a bias that we look for steady signals, and until recently, very narrow band signals, when in fact, that's not the way you'd build a beacon. You'd make it repetitive. You'd have it bandwidth sufficient to put a real message on. There are lots of biases because, you see, where did this bias come from? Well, astronomers are observers. But beacons or power beaming, what we call them beamers of high power, are built by people who build things, not observe things. So they have a very different perspective. And astronomers tend to have the perspective of listeners. But the objects they're listening for in SETI would be built by engineers, not astronomers.
Say a probe. All right, there's two ways to think of an alien civilization. You can think of it as a positive thing, that it wants to communicate and it wants to collect data and it wants to figure out if it's alone in the universe. Or it could say, I want all of this material, that's present in this galaxy for the eventuality that this galaxy is going to die, along with the rest of the universe. What chance do you think that a probe, a malicious one, that might detect us at a certain level of technology and EMP us back to the Stone Age, do you think that that's an equally possible scenario, or do you think it's not likely?
Well, knowing how difficult interstellar travel is at our present level of technology, it would seem like a remote possibility from our point of view now. However, it's a choice of whether or not to, say, respond to a signal. The so-called METI question is something that we ought to have a discussion about as a society. And I don't mean just us insider people who think about these things, but the greater society should be prepared to have some protocol for how we would respond that has general agreement. And so we would know what to do. After all, but the way things are done in Earth's politics, it would take us years to reach agreement if we received a signal now. So we should be talking about that now and be ready. As this pandemic has taught us, being ready for things is a whole lot better than whistling Dixie and pretending it'll never happen.
Absolutely. And this is what we're talking about is very different from some distant radio signal or detection of a technosignature or biosignature, light years away. This would be right here. And it could pose a threat to global security, potentially. And so you say we should be discussing this right now. And it's an imperative, right?
Yeah, I think so. It doesn't. Responding to a beacon would not involve great resources, some resources for sure, but nothing on the scale of real catastrophes like hurricanes. So I think we ought to talk about what we would do. There has been some discussion, but it's really insider discussions, and let's put it this way: the UN's never really talked about it seriously. And I think we should put together conferences, symposia of people knowledgeable in all of the sciences, including the social sciences, and people who with an understanding of the political theater and economics, to discuss this from many perspectives, and that discussion would gradually diffuse into the population, and people would get familiar with the arguments. So we'd be further along the road toward making a choice in case something should be detected. And now that there is a big program, the Breakthrough Listen program, sponsored by the Breakthrough Foundation, the same people who sponsor Starshot, of spending $10 million a year listening, the probability of finding it, whatever that is certainly much greater than it used to be. So we ought to be preparing for what we would do if we found it.
Now, invariably, and I'll preface this in that I am a skeptic, but invariably people are going to leave comments about the UFO phenomenon. Do you think we should take a look at that, or do you think it's just bunk?
I find it very hard to think of it as credible. Certainly the idea of alien spaceships zipping around near Earth and not being detected by all the radars and all the observers we have now seems to lack credibility. The only explanations that could fit with that fact are that they are somehow time machines or coming out of hyperspace or some other technology that's so advanced that it fits Clarke's law, that it's a sufficiently advanced technology is indistinguishable from magic. UFOs appear to be kind of magical. The observations that are reported show them moving at very high speeds and high accelerations that we couldn't build an object to do. So I think they either don't exist, they are all illusions of some kind, or they're very advanced and we were not going to be able to understand them or detect them.
Now, to close this out, Doctor, what is your gut feeling on finding an alien artifact in the solar system? Do you think it's likely, or do you think it's unlikely, but should be looked for? What's your gut feeling? Do you think that the solution to the Fermi paradox is that we're not looking close enough?
Yes, I do agree with the latter. That is, I think we just haven't looked for an entire class of possibilities, the artifacts. And I argue in this community that that's of roughly equal probability to listening to beacons, and we're certainly doing that. So we should be looking for artifacts. Also feel that we will be doing good astronomy because we'll be studying objects near us, objects like the CoOrbitals that we know essentially nothing about. So it's a net positive. I think they really might be there. And the fact that they might have been there for a very long time would tell us something about the history of the universe.
And the fact is, we do have a sampling of one. We are a civilization. And if there's anyone else out there, we are their alien civilization. And we are their answer to the Fermi paradox. So the fact that we exist and can even look for this kind of thing suggests that, why not? Why not?
Yes, well, we've got an existence proof. It's us.
All right, Doctor, we are out of time. Thank you very much for appearing with us, and I hope someday you'll come back and we'll have another discussion like this. So here we arrive at distance again. If some distant light-years away signal were detected that proved the existence of other civilizations in the Milky Way, would that be all that surprising? I don't think so. I think most people are at least receptive to the idea that we may not be alone. And I'm not sure that the predictions of social upheaval that have surfaced over the years would actually play out. Indeed, a radio signal from a distant alien civilization would capture the attention of the world, but there would also come a time where it leaves the news cycle, at least until more information about that civilization is gleaned, something that could easily take centuries. It's the we know they have radar scenario, where we know a few things, but not a lot. 50 years later, we still know little else. But again, think about distance. What if the detection were close? What if it were on the moon? This is a question well asked in science fiction and pop culture. But would we really be so comfortable with something of alien origin that close to us? It's a very interesting question to ponder indeed.
John, are you the same John as on your other channel?
What?
You appear to have 2 channels, John. Some even say 3.
Yeah, that's the baryonic matter, JMG. Does he ever have it easy? He just writes science monologues at night over cups of tea and goes with it. I, on the other hand, have to do deep research and talk to guests. It's not as easy as you think.
How did you do that? You both have beards. John, the anti-universe and the normal universe. I think you're the same. Or at least one of you is the evil John.
Yeah, I wonder who that's gonna be. That's not me. Not me either.
Oh dear. 3.
But anyway, that was just Spock ruining beard styles. There is no rule in the universe that says that alternative universe copies of humans can't both have beards.
Yes, John. You keep believing that. It keeps the channels consistent.
Well, I'll just get a physicist in here to explain it to you, Anna. You could cut the subversion in this room with a knife. And on that note, join us next week for a very special show indeed. See you then.